going to talk about tables in table storage today. Setting up a table follows the same basic steps as blobs and queues. You have a storage account, you have a storage container type that you've declared, and then you have storage account connections that you map the different environments to those account and container types. Then you end up in the table storage shortcuts. We've created two here. Testing works much the same way as it does in the other storage APIs. We select our shortcut, we know we've mapped to an environment, and now we can actually do the testing. Table storage is a little unique in that you have to know the class or the structure that you're going to query against or project into ahead of time. AzStudio has overcome some of this by creating this AZ table entity with which you can descend from and implement your own queries. Now, the AzStudio APIs all follow off of an AZ table entity, which implements the mechanics of the Azure iTable entity interface. But it does a few more things for us. If your class descends from AZ table entity, you can do dynamic projection of generics. And this lets you do these kinds of operations, which is if your plugin or library that's part of AzStudio is present and implements this AzStudio table entity, then you can query for it dynamically without having to hard code the class type or the interface type. In any case, you should probably use the AZ table entity as your base class and descend from it. Makes things a lot easier, and our APIs kind of want that. Now this testing tool is pretty basic. It lets you create your own filters if you want. I'm going to remove this and just do a straight filter, which means I'm going to select just the rows in the order that they were entered. And then I'm going to read 10 items. And as you can see, we get the same cache miss and lookup that we had in our other APIs. And we've got a projection of the AZ table entity from that table. So we know we can access it. We know we can get some basic data out of the system. Now that's great and all, but it'd be nice to see a practical use of the table storage APIs. And we happen to have one ready for you. So we're going to look at our binary tree table storage operations. Now that's great and all, but it'd be nice to see a practical use of the table storage APIs, and we happen to have one ready for you. So we're going to look at our binary tree table storage operations. It's also good at showing off a practical example of tables and some of the patterns that you can use when accessing tables. In this example, we're going to look up random names. We're going to use it to drive a suggestive search interface and show you how we can take that suggestive search item and extend it through a data field. Now, the first thing we're going to do is show you our partition strategy. So I'm going to come in and type my first name, and we're going to show you how the system would set up its partition keys for my first name. This lets you see how a partition strategy could be put together for a fast lookup, but it's also showing you how a fundamental principle of table storage works, which is denormalization. Whereas SQL is interested in optimization and normalization, table storage is not. Okay, so we've already loaded this table with a bunch of data for you, so let's go look up. Let's go test our lookup. Let's do this, and let's just test A. As you can see, we did a round-trip query on A for 5 items, and you'll notice that we get 5 JSON results back, which means that we are querying that table store, and we are getting back a bunch of data. You'll notice that we have a partition key, a row key, but we've also been able to attach data as a JSON object to that row. This is denormalizing data that you need to look up very quickly and attach. Our APIs make this a real cinch to accomplish. And now we'll look at a little bit more of a live demo here. We're going to get our combo box here. This happens to be tied to a Win32 app, but it can just as easily be tied to a web interface and a web service. As you can see, it's pretty fast. CA, CE, there we go. As you can see, it's really quickly talking back and forth from the server and giving you suggestive search. And this is just one quick example of using the AzStudio APIs to talk to table storage. The programmer, all they have to know is the actual table storage shortcut, which is lookup, they don't need to know much else. Once the programmer has the table storage shortcut and you've tested it with our testing tool, you can be assured that that table store is available for the programmer. Everything that the table storage APIs support are of course supported in AzStudio with the usual caveats of federation, transient fault handling, and advanced logging, all set up for you. In addition, the B-tree set engine is actually a background worker that goes along with this configuration that you see me playing with. And we can take data sources that you set up in the configuration manager and map them to table storage. If you have a SQL server that has information that you would like to denormalize, then this engine can take care of that for you. Same for another table storage source, a document DB source, or a full text source, which is be binding it to our search technology. In any case, it's possible to set up these sets, point them to different data sources, and build these quick lookups all over your system, and then attach data to those results, those row results, using a JSON data template. Therefore, you don't have to write all this stuff. You don't have to write all these indexers, and you don't have to optimize your table storage. It'll all be taken care of for you. So that's the basic of table storage. You'll have to examine our API for further information, but we have a rich, robust, both indexing engine and access API and projection API built into AzStudio Common.